Okay, so this question says the equinox is the moment the plane of the Earth's equator passes the centre of the sun. The Northern Hemisphere countries such as Ireland, for Northern Hemisphere countries such as Ireland, the day on which the spring equinox falls is the day from which the number of hours of daylight begin to exceed the number of hours of darkness. The autumn equinox is the date from which the number of hours of darkness begin to exceed the number of hours of daylight. The solstices are the longest and shortest days in terms of hours of daylight, respectively. In fact, this information is slightly inaccurate, but we will assume it is correct for the purposes of this question. Okay, all of that was absolute nonsense. It says at a certain latitude, the number of hours of daylight in each day is given by the equation D equals, so now I'm getting important stuff because they're giving me an equation. Okay, they say D equals A plus B sine KT. Sorry, small t for time. Okay, where A and B are positive constants and T is time in days since the spring equinox. Okay, so T is time in days since the spring equinox. Now, spring equinox, let's look at our table. Okay, I have equinox here and equinox here. One is in March, one is in September. Obviously, the one in March is the spring one. The one in September is the autumn one. Okay, so the spring equinox for us, so this is us here in 2014 is what we're looking at in this question. Okay, so it's the 20th of March. Okay, so the 20th of March. So time in days since the spring equinox. So since the 20th of March. Okay. Okay, so this is it. Okay, A, remember, is the horizontal midway line. B is the amplitude of the sine graph. K is what is usually C. Okay, so it's the 2 pi divided by whatever the period for this question is. Okay, so part 1 says, given the fact that it takes the Earth 365.25 days to complete one orbit of the sun. So that has to be giving me some piece of information. It's telling me that, remember, these equinox things and the solstices, they repeat themselves every year. Okay, so when it's saying it takes the Earth 365.25 days to complete one orbit of the sun, after that orbit, it's all going to start again. Okay, so how am I going to get C, or in this case K? Well, I'm saying, okay, this is how often it repeats itself. Okay, so 365.25 days. So I am going to say 2 pi divided by this 365.25 days. Okay, so put that into your calculator and see what K is. Okay, we haven't even been asked for anything yet, but I've just been given a piece of information there, how much it repeats itself. Okay, so I'm just going to be trying to fill this in if ever I get some pieces of information, which in this case I just have. Okay, so 365 divided by, 2 pi divided by 365.25, I get 0.017202. Okay, so that's what I'm going to put in before K here. And it says, show that the value of K to 3 significant figures. Okay, brilliant. So we're getting the value of K here. So we've already done this. Okay, it says 3 significant figures. Remember, significant figures are the first numbers that aren't 0 is where we count that from. So it's not decimal places. So the 0 doesn't count here. So 1 is my first significant figure, then 7, then 2. Okay, so that's where I bring it up until. Okay, so it's 0.0172 is what K is. Okay, and they say show that the value of K to 3 significant figures is 0.0172. Brilliant, that's what I've gotten. If you didn't get this, or if you rounded it wrong, okay, that might give you a little bit of a reminder as to how we do it, that they gave you the answer in the question. Okay, remember now, we used 2 pi as how often it repeats itself. Well, actually, sorry, it repeats itself every 365.25 days. But what I mean is we use 2 pi as the reference period. Okay, that's meaning that straight away for the rest of this question, your calculator should be in radians. Okay, it should not be in the setting of degrees. Okay, it then says a town at this latitude called Anvari has a weather station that records exactly 6 hours of daylight on the shortest day and 18 hours of daylight on the longest day. So using this information, calculate the values. Okay, so this is what I have. Okay, they've just basically, if I'm looking at the hours of daylight, they're always going to be slightly increasing and then decreasing and increasing and decreasing. But they've just told me, and we know that there is like a minimum amount of hours of daylight. We never go into like a full day of darkness or like minus hours of daylight. Okay, so they just told me that this minimum that it goes through each year. So let's say this is my sine graph here. Okay, the minimum it goes through, the minimum amount of sunlight each year is 6 hours. Okay, so it's telling me there that the minimum amount of light is 6 hours. Okay, so this axis is my daylight and this is the time that I have. Okay, so it's 6 hours, and then the maximum amount of daylight that there is 18 hours. So that's what the question just told me. Okay, so when I'm following this curve here, so this is 1 year in before it starts again. Okay, it just goes increases, increases, increases up until its highest amount of daylight, and then it starts having less and less and less, and so on. Okay, so it says that it records exactly 6 hours of daylight on the shortest day and 18 hours of daylight on the longest day of 2014. Using this information, calculate the values of constants A and B. Now, constant A is the halfway between 6 and 18. Okay, so there's 2 ways to think about this. Like, A has to be, it's always going to be the horizontal midway line, the Y value for that. You also could think about it as the fact that, like, for daylight to start being more than darkness, or darkness to start being more than daylight, it has to go past that 12-hour mark. Okay, but if we just think about it in terms of this, okay, when it's that horizontal midway line, it's exactly halfway between 6 and 18. Okay, so for A, let's get the average of 6 and 18. Okay, so let's add them both together and divide by 2, and we see that the answer is 12. Okay, that makes absolutely perfect sense, because it makes sense with what they've explained in that first paragraph, that the daylight has to either start being more than the darkness in the spring and then less than the darkness in the winter, or autumn equinox is like around here. Okay, so at 12, that's when the time starts changing between them. Okay, so A is going to be 12. And then B is the amplitude, so how much it goes up from A and how much it goes down from A. So it's going up 6 and down 6. Okay, so B, the amplitude, is 6. Okay, so that's great. That means that we can now write in our function. Okay, so now, because I have A and B, I have the function that the amount of daylight is 12 plus 6 sine 0.0172 t. And it says for part 3, calculate the amount of daylight in hours and minutes that the town of Anvari will have on New Year's Eve in December 2014. So it wants me to find the amount of daylight, D, and it gives me the time. It says it's New Year's Eve in December 2014. Okay, so remember how we get time? It's the amount of days since the 20th of March. So we need to count up how many days there are between the 20th of March and the 31st of December. Okay, so when we count that up, we'll get, so for part 3, okay, we're going to get that T is 286 days. Okay, so we're just going to fill that into our formula. So we're going to have 12 plus 6 sine 0. So let's put this in brackets, 0.0172 times T. So again, you can just use the multiplication symbol in your calculator if you want. I don't want to close the bracket after this in case it thinks that I just want sine of just this. Okay, so even do out this multiplication first and then get sine of that if you want to. Now remember what we said, our calculator has to be in terms of radians because up here I use 2 pi. Okay, so that's a measurement in radians. So make sure your calculator is in radians when you're getting this. So we have 12 plus 6 sine 0.0172 times 286. So it is 6.1278571. Now it asks for it in days and minutes. So I'm going to press the days and minutes button in my calculator. It's just below the square root button. So it gives me that it is 6 days, 6 days, 7 hours. What am I saying? 6 hours, sorry. 6 hours, 7 minutes and 40 seconds. Okay, so the question says, calculate the amount of daylight in hours and minutes. It doesn't say anything about seconds, so I'm just going to round that to the nearest minute. Okay, so obviously 40 seconds is more than a half a minute, so I'm going to round up the minutes to 8 minutes. Okay, so 6 hours and 8 minutes is how much daylight there is on New Year's Eve in December 2014. And then the last question says, Anvari holds a traditional town fair called Staralfer on the 2 days on which there are 10 hours of daylight. On what 2 dates in 2014? So it's given us a massive hint here, okay? I'm going to just rub out a lot of what I have just so I can write out what I've been given. So for part 4 here, it gives us a massive hint in saying that there are 2 possible days and it gives us the amount of time. So my function was that D is equal to 12 plus 6 sine 0.0172 T. And they have now told me that D is 10 hours. Okay, it's the day when there are 10 hours of daylight. So we need to figure out what the value of T is here. And the massive hint that it gives me is that is that there are 2 values for T. Okay, that is a massive hint. Okay, that reminder. So if it didn't even mention that, we'd still know how to start going about this question. Okay, we'd still know how to start going about getting like an initial value for T. And that would be just to fill in that D is equal to 10 and then try and move a few bits across the equals. So if I was to do that, okay, which is the perfect way to start, and I'm going to do it like that before I overcomplicate it trying to explain, but it is going to be slightly more difficult later on. Okay, so I'm going to minus 12 from both sides so that I get minus 2 is 6 sine 0.0172t, and then I'm going to divide both sides by 6 so that I have minus a third, is the sine of this angle. So this is the main thing, is that the sine of the angle is giving me minus a third. Now, when does the sine of an angle give you a negative answer? Okay, when does the sine of an angle give you a negative answer? What quadrant see it in? So think about this. Okay, think about stack. Okay, if you're in the first quadrant, it's never, the sine of an angle is never going to be negative because all of them are positive here. In the second quadrant, the sine of an angle is going to be positive. And then it's in the third and fourth quadrants that the sine of some angle is going to be negative. Okay, so what I'm going to do is, I'm going to say, okay, let's get rid of this sine. Okay, let's do the inverse sine of a third. Okay, so that I figure out what this is. But what I'm actually going to be getting is my reference angle. Okay, so if I get the inverse sine, okay, so I'm going to get the inverse sine of just a third, okay, not even minus a third. Now we know from our log tables that it actually doesn't make a difference. So remember, the sine of an angle is the same as the sine of minus that angle. Okay, so it doesn't actually make a difference. But I'm just going to say, let's just make it positive and just get it as a reference angle. Okay, so what I'm doing here is saying, okay, so what is that initial angle that I'm getting? Okay, so 0.0172t. So put the inverse sine of a third into your calculator. Again, make sure your calculator is in radians because we used 2 pi earlier on, so we have to use that radians idea. Okay, so the inverse sine of 1/3, put it into your calculator, and we get that it is 0.3398369095. Okay, that is what the inverse sine of a third is. Okay, so this angle is my reference angle. So that could have been made in this quadrant, in this quadrant here. I could have made it in this quadrant here, in this quadrant here, or in this quadrant here. Okay, but because it was actually initially a minus a third, the two angles that it must be are the angles that I've just drawn in the third and fourth quadrants. Okay, so the third quadrant where only tan gives us back a positive, and the fourth quadrant where only the cosine gives us back a positive. Okay, so this here angle that I'm getting equal to 0.0172t. That's actually not the angle, because in this quadrant here, okay, it would have given me back the sine of this number here would have given me back a positive third, whereas I need that to be in some quadrant where it'll give me back a minus a third. So it needs to be in this third or fourth quadrant here. So we need to figure out what that number actually should be. Okay, so we're going to switch this up slightly. That's not the actual angle, okay? It's the reference angle with the horizontal line. So that is my reference angle, and I need to figure out what the full angle is. So this full angle here for the green one. Okay, so 2 pi is 180 degrees, that full line there. Sorry, pi. Okay, so that full line there. So let's add on that little bit of a reference angle, okay, to get the one that's in the third quadrant. So in the third quadrant, it's going to be pi plus 0.3398369095. And just when you get that answer in your calculator, just press store. Okay, so it's shift and then that RCL button, okay, because it says STO on top of it for store, and just store it as a letter. So just click like A, okay, so, or the minus that has an A on top. That means that anytime you press alpha and the minus to bring A up, it brings up that number with all the decimal places. So you don't have to waste time typing this full number into your calculator loads of times. Okay, so in the third quadrant, we're going to add pi onto that number so that we get 3.48142953. Okay, so that's one number that's going to be equal to the 0.0172t. And then the other one is the one that is in the fourth quadrant. Okay, so it's easiest for me to say, okay, well, if it went around the full way, then that would be 2 pi. So let's say, okay, 2 pi, take this reference angle away. Okay, so in the fourth quadrant, it's going to be 2 pi minus this 0.33983699095. Okay, and even if I actually wrote that out slightly wrong, that's okay because I have the proper number stored into my calculator. Obviously, it's nicer if you don't write it out wrong, but still. So 2 pi minus A, or whatever all this is, whatever letter you stored that as. Okay, and we're going to get 5.944398. Okay, so that's another thing that is equal to 0.0172t. Okay, over here, I should have left space underneath this one to finish it off. I'm actually just going to finish off this one while I have the numbers in my calculator first, and then I'll go back up and finish off this one. So to get this one, I just want t. I have 0.0172t. So I have to divide that. So divide all this by 0.0172, so that I get 345.5435115 is t. And then up here, I should have saved that, but it's okay because I'll just quickly do my calculator again. Pi plus A to get that number, and I want to divide it by 0.0172, so that I get 202.408695 equal to t. So I have gotten that t is 202 days, or t is 300 and let's say 340. We can say either there. I'm actually going to say, because it's full days, 345.